This is Ultraviolet Rays by Raina Estrada, Ray Bagwell, and Kyle Hall.
Ultraviolet light is more energetic than visible light, but is mostly blocked by Earth's atmosphere. The higher energies of UV rays make it more damaging to human skin cells, so make sure to wear your sunblock.
UV light is light with higher frequency and lower wavelength than visible light. The frequency range is 8 times 10 to the 14th to 3 times 10 to the 16th, while its wavelength range is 10 to the negative 8 meter to 3.8 times 10 to the negative 7th.
UV rays are components of radiation by the sun and can be split into 3 different sections. UVA, which is 320 to 400 nanometers, is responsible for mostly skin cancer and melanoma. UVB is the range from 280 to 320 nanometers. It's a stronger radiation and increases during the summer, and it's most common for sunburn. UVC is below 200 nanometers and is the strongest, most harmful form of UV light.
Now it all began in 1800 with Friedrich Herschel, a German astronomer, that watched sunlight pass through a glass prism. He noticed as the temperature increased, it moved towards the red end of the spectrum. He measured the red beyond the end of the spectrum and named it ultra-red. Only a year later, Johann Ritter, a Polish physicist, did experiments with silver chloride at the University of Jena. He used light-sensitive material to pass different colors through a prism. He saw an intense reaction with the silver chloride that went past the red spectrum and found violet light, he later called chemical rays. What Ritter discovered as chemical rays were later termed as ultraviolet light. One well-known use of UV rays would be coming from the sun. It stimulates production of vitamin D in our bodies that helps us grow. It strengthens our bones, our teeth, and our bodies build immunities to diseases like rickets and colon cancer. Thanks to the help of UV rays in astronomy, we are able to gain extra information such as temperature and chemical chemistry of planets, stars, nebulas, and galaxies around us. You can also find UV light in fluorescent lighting around your home and in your school. Substances are able to absorb the change in UV light and convert it to visible light or fluorescence.
It has been proven for decades to effectively disinfect air, surfaces, and water.
Ultraviolet disinfection is a very interesting process. By UV disinfection, you're basically killing the bad guys. There's a certain wavelength at which bugs, viruses, and pathogens become zapped. So all you have is ultraviolet light, and that is radiating out at a certain wavelength. And at 254 nanometers, the DNA structure of the microorganism gets dormant. It affects the DNA structure, so the bugs cannot reproduce. And for all intentions and purposes, it is considered to be dead. So what you have is a plant which has got the ability to zap the microorganisms as it swims past the bulbs. And at the end of it, you do not have any of these UV rays carrying through, nothing of that sort, because it's actually at a microbial level affecting just the cells.
These are a few interesting facts about UV rays.
UV rays can penetrate glass to an extent, which means you can get sunburnt in your car. Apple juice or cider is treated with UV light to reduce the number of microbial pathogens. UV rays can be used with a powder to detect finger and shoe prints to help solve a crime.
Another interesting use of UV lights have been that they have been installed in some parts of the world in public toilets and transportation to deter people from substance abuse. UV rays are especially important to bees because they use it to see. They use the reflection of the UV radiation on the flower petals to guide them to the pollen inside the flowers.
Find the frequency of a light that has a wavelength of 1.2 times 10 to the negative 8. So you're going to use the formula C is equal to lambda times frequency. And so C is going to be the constant, which is 3.0 times 10 to the 8th. And that's going to be equal to our wavelength, which is 1.2 times 10 to the negative 8 times our frequency, which is what we're looking for. And to rearrange that, you're going to make that F is equal to C over lambda, or in other words, 3.0 times 10 to the 8th divided by 1.2 times 10 to the negative 8. And then when you divide it by that, you'll get your answer. And so 2.5 times 10 to the 16th power is going to be your answer. In this second problem, find the wavelength of a light that has a frequency of 8 times 10 to the 14th. So again, you're going to use your formula C is equal to lambda times frequency. And for your problem, the C is still constant, so it's still going to be 3.0 times 10 to the 8th. And then that's going to equal the frequency, which is 8 times 10 to the 14th times lambda. And when you rearrange that, it's going to be lambda is equal to 3.0 times 10 to the 8th divided by 8.0 times 10 to the 14th. And then once you get your answer,
yeah, waxing for brain doesn't hurt.
And then you can put it in scientific notation. So it'll be 3.75 times 10 to the negative 7 meters.